Okay, fourth installment of the Final Exam Review video. So, we've done these kind of problems before. You buy a large painting, and you want to make a frame. How wide does the frame have to be? Um, so here's the frame. Here is the picture. That's X, 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 X. So remember, X is like the width, all the way around. And then that's 5 from here to here. And 6 from there to there. Remember, area is length times width. So that's 5 plus 2x, one dimension. And that's 6 plus 2x, that dimension. And the area of the whole thing is going to be 42 because you got 30 for the picture and 12 for the frame. And it's going to equal 5 plus 2x times 6 plus 2x. Work it out. Factor 2x minus 1 plus 6. See, x goes half or negative 6. So the answer is half a foot because you can't have a negative dimension. 22. Maybe if you guys forgot the sign chart, and just like with the standard form for complex numbers, I was a little disappointed you guys forgot that. It's pretty important, but again, I'm sure you guys have a lot on your plate, so here it is. Gotta remember the sign chart. So when I say use any method you like, there's an algebraic way or a graphing way. I don't think I spent enough time on the graphing. I did show it to you, but I didn't spend enough time with algebraic. I have. The algebraic way involves a sign chart. Graphing, I think, is pretty obvious. You're going to graph on a coordinate plane. But let's start with the algebraic. So we put everything on the same side, and we factor. So I factor out 4. So you have x plus 2, x minus 1. Now this is the part that I need to caution you about. It's not an equation where you can say, oh, x equals negative 2, so x is greater than negative, or x plus 2 is greater than 0, then, oh, x minus 1 equals 0, or x minus 1 is greater than equals 0, so x is greater than 1. You cannot do that. There has to be a range of values I have to look at, so that's why we do a sign chart. Well, of course, we want to know the zeros are negative 2 and 1, but then you do a sign chart. So you can see which intervals will satisfy the inequality. So negative 2 and 1 are just the boundaries, because they make the inequality 0, but then is numbers to the left negative 2 going to make it greater than 0? In between negative 2 and 1 going to make it greater than 0? Or to the right one, is that going to make the expression greater than 0? So we test points. I'll use orange here. Let's mix it up. Negative 3, 0, and 2. If you try negative 3, you're going to have 4 times negative 1 times negative 4 if you plug it in. So that will be positive. If you plug in 0, you get 4 times 2 times negative 1, that will be negative. And remember, I'm plugging into this over here. If I plug in 2, I get 4 times 1 is 16, that's positive. So clearly I want these regions, and I don't want the middle region. So x has to be less than negative 2, less than or equal to negative 2, or x has to be greater than or equal to 1. So any x values that follow that range will make the inequality true. So you got to use the sign chart if you do it algebraically. If we graph it, which is fine, all you have to do is just show me your graph. So if you graph it in the calculator, you'll see a graph that looks something like this. Now, if the equation, it's not really an equation, I gotta be careful with my words. if the quadratic expression is greater than or equal to 0, then you want portion of graph to be above the x-axis. And vice versa, if it's less than 0, you want it below. Because remember, the quadratic expression is what we're setting y equal to. Well, where is it above? Clearly here, and clearly here. And let's change that. So the x values that correspond to the portion that is highlighted here should be pretty obvious. The left side starts at -2 and goes to the left, so we say that. The right side starts at 1 and goes to the right. And that's what we have. So that's 22. Okay, 23. This is a behemoth of a problem, but could be in the final. So we plot our points. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's change colors up. Let's go dark blue. 0, 3. -2, -5. And 3, 0. So we have a parabola that looks like this. Pretty looking parabola. You gotta find the equation for parabola though. So use these points to find equation for parabola. Well, here's the equation. Y equals ax squared plus bx plus c. And what you can do, because vertex form is not really going to help me because I don't know what the vertex is. Intercept form is not going to really help me because I know one of the x-intercepts, I don't know what the other one is exactly. So that's why it probably makes sense to just use standard form. So 0, 3 gets us this, right? 3 equals 0 plus 0 plus c, so c equals 3. -2, -5 gets me -5 equals 4a minus 2b plus c. But I already know what c is. So 4a minus 2b will equal -8. And then 3, 0 will get me 0 equals 9a plus 3b plus c. I already know what c is. So 9a plus 3b will equal -3 when I move it over from right to left. Solve for a and b. So you have these two equations, right? So if you solve for a and b, a should equal -1 and b should equal 2. You guys should not do this by hand. You did this in Algebra 1 many, many times. You can use elimination or substitution. Or use a Solve2EQ program, your calculator. Either way. Okay, then we have our equation. So finally, all that work. So y equals -x squared plus 2x plus 3. Now they say it intersects, or we want to find the area of the region bounded by y is greater than or equal to 2 and the parabola that involves those points. So the enclosure obviously will be, let's change colors, I don't like that color. There we go. Sorry about that little green thing in the middle. So we need the points of intersection. Need points of intersection. Maybe you guys forgot how to find points of intersection. Well, if you have two things that cross, to solve for points of intersection algebraically, you just substitute, right? You already know that y equals -2 for the green line, or sorry, for the blue line, right there. You already know y equals -2. And you know for the parabola y equals -x² plus 2x plus 3, you want to see what points they have in common, so it only makes sense to set those two equations equal to each other, or substitute. So that's what I'll do right here. -2 equals -x² plus 2x plus 3. Then use quad form by hand, which again you guys should know how to do. So 0 would equal -x² plus 2x plus 5. If you do quad form by hand, you should get the following. X equals 1 plus or minus √6. I won't work it out. I'll let you guys do it on your own because that takes too much time and too much space. So it means that the points of intersection are the following: 1 minus √6 comma -2, and 1 plus √6 comma 2. And this right here is going to be my base. So my base is just going to be the difference in those x values. That's how we subtract, or that's how we find this between 2 points. If they're on a horizontal line and the y values are the same, just simply subtract the x values, so we get 2 √6 for the base. The height, we need the vertex. That'll be 1 comma 4. You guys should already know how to find vertex all the way from the number 18. We talked about it right there, so I'm not going to explain how to do that. You can also use a calculator. You can use the second trace. Max. You can find that as well. So your height will be 6, because that's simply subtracting 4 with -2. So height is 6. So the area will be 2/3 BH, or 2/3 times 2 √6 times 6, which will give us 8 √6 for the area. Okay, then 24, and I need to take a little break because I'm getting kind of exhausted here. Okay. Well, remember that if these are your solutions, x minus 1/3 would have to equal 0, and x minus 3/4 would have to also equal 0. Or x minus 1/3 times x minus 3/4 has to equal 0. So if you FOIL it, you get x² minus 1/3 x minus 3/4 x plus 3/12. So we can multiply everything by 12. 12x² minus 4x minus 9x plus 3 equals 0. So 12x² minus 13x plus 3 equals 0. And remember, we want integer coefficient, so integers no decimals. Just whole numbers, like, well, not whole numbers per se, but positive or negative numbers that don't have decimals. Or 0 obviously counts as an integer too, I guess. But yeah, that's what we have for that one. Okay, let me stop the video.